When one creates a model from scratch inside of Rhino, all of its components are stored inside the current file. Surfaces, curves, points, etc. When creating a copy, an identical but completely independent part is made. Each of them may get further edited separately with all the tools Rhino has to offer. Also, in terms of rendering, these individual items behave reliably. Each new material assignment does what one would expect. There's cases, however, where objects might seem to act in unexpected ways. These two objects look exactly the same as before, but whatever material I drop onto, they just don't seem to care and stubbornly go on rendering as red plastic material. In the next couple of minutes, I'll explain a bit what's going on here. This clip is about working with instances, Rhino's blocks, as well as Maxwell's scene references. As this is a pretty large topic, I won't be able to fit every possible scenario into this clip. I'll only give an overview of underlying concepts with a focus on rendering with Maxwell. For the specifics, there's always the manuals for Rhino and Maxwell respectively. Using instances generally improves the work with great amounts of identical parts. This property may help rendering large scenes, as cloned geometry needs far less computer memory than unique objects. This can be especially helpful in cases where one still has to work with 32-bit machines. With identical, I mean the underlying topology. This here are all instances, and each of them may still get freely transformed individually. Rhino's native incarnation of instances is called blocks. One roughly can work with them in two different ways. The first way is that we as users create them from any item in the open scene through Edit, Blocks, Create Block Instance. As soon as one has gone through this dialog, one is actually free to create duplicates and to arrange them in the scene. A double click on any of the instances opens up the Block Edit dialog. With it open, one may for one change the geometry and all instances will have to update. As the geometry for this block has been created inside of Rhino, the program can find all necessary informations which define the part. With the block edit dialog open, one may also change how Maxwell's material assignments work. When the object already has a material assigned, any instance will simply inherit that material. If you had no bespoke material assigned, Maxwell will simply use its default gray material. At that point, one cannot simply change the render material, and this may cause some irritation. The material is properly assigned, but it simply doesn't appear in rendering. The reason is that the assigned material is actually stored inside the block definition. To change the render material, one therefore needs to enter the block by double-click on any of the instances. At this point, one may assign a new material directly. If I now say OK, the new material will get stored inside the block. Now every single of the instances will carry the same material. If that isn't what you want, and you'd rather want to be free to assign any material to block instances, that works as well. For this to happen, one again needs to double-click a block instance, and while the block edit dialog is up, one goes to the material page for the selected object. When one here changes the material assignment to by parent, and finishes the block editing by pressing OK, one may now assign any material to any of the instances. Make sure that you do this while actually editing the block, otherwise it simply won't work. That's in a nutshell the first way of working with blocks. The geometry has been created inside the current file, and while blocks are somewhat encapsulated, there are still all sorts of editing options at disposal. Then there's options to bring in existing files as blocks by using File Insert or simply by drag and drop. In the pop-up, one may now choose to insert that particular file as a block. Here one gets three different options offered. The first one essentially will make the inserted geometry behave as if it had been modeled inside the currently open file. Rhino reads all geometry information first, and afterwards it encapsulates it into a block. With an embedded block, one may use block edit inside the open session of Rhino and essentially has all options I discussed a minute ago. I'll skip over the second one for now and use the third option, link, instead. Although the block still looks like any other Rhino geometry, this time just enough information is loaded to display and render inserted items properly. For that reason, Rhino can't edit the inserted part directly. On double click, I'm suggested to open the original file in the second session. Here the program again has all information available. I can do my edits and simply resave. The linked option may make sense when it's an advantage to keep things neatly organized as separate files. Another interesting use for linked blocks can be geometry in third-party formats. Finally, the second option, embed and link. With this option chosen, one doesn't have to decide yet which route to take. Parts are inserted as usual. The point where one wants to change the inserted geometry is the junction here. Upon double-click, one is asked whether one wants to change the external source file or create a unique part which lives as a block in the opened file. Hopefully this all makes sense, but there's of course more complex cases, because one may put a block into a block and yet another block, each of course with its own respective properties in terms of being embedded or linked. In case it's you who deliberately creates such nested block constructions, there's probably not much need for further explanation. But there's yet another area where one may have to deal with nested blocks, even if one doesn't want to. That is, automatically created blocks. One will likely run into them already when using the normal file open command on certain third-party geometry. Instancing, or some sort of smart clustering, obviously takes place in a great variety of programs. AutoCAD, for instance, calls its clusters blocks as well. SketchUp calls them components, but also the entire hierarchical structure from feature-based solid modelers may translate into blocks when importing such files to Rhino. Here I'm going to open a nice bicycle model which has been created in SolidWorks, and it gets imported as a step file. It's a very large file, the conversion takes a bit, so I'll speed this up. Now the file is loaded and one can already see that everything in here is just one single block. One can get rid of it by running Rhino's explode command. This spits out a few more blocks which are again comprised out of sub-blocks. One option would now be to get rid of all these blocks, and there's quite a few good reasons for this. There's no more access to the parametric features. It's dumped geometry now. Also, Rhino 5 doesn't like deeply nested blocks at all. They may have a massive impact on interactive performance. Having all the geometry in the file as polysurfaces would also give us editable geometry, and also material assignment and texturing was much easier. In order to get rid of all blocks, I'd suggest not to use the normal Rhino explode command, but rather explode block. It does the entire job at once. In the end, there's only NURBS geometry left. In the concrete example of this bicycle, however, it might be worth doing the cleanup manually. The model consists of a great number of repeating identical parts, as the spokes, and in particular the chain, and being able to edit them all at once certainly wouldn't hurt. Also, exporting to the render engine would work out much faster. But leaving single elements as blocks really makes no sense, such as this brake disc. This one can safely get exploded to a polysurface. Maxwell recognizes all of Rhino's blocks. When pressing the render button, it automatically exports them as Maxwell instances. But the program actually has also its own concept of linking files to an open Rhino project. It's called MXS references. That is the abbreviation of Maxwell's scene references. Using this principle, one can load content types and file formats which natively aren't supported by Rhino as the host program. MXS files really only contain what's strictly required for the engine to calculate an image. There is no more surface data included, or curves or points, or any sort of other data which the engine can't interpret anyway. Scene references are just linked to the open Rhino file. Therefore, they use very little resources. They are basically nothing else but a normal Maxwell scene file, which gets written every time one presses the render button. That means that one could in principle use every existing Maxwell scene file one has on disk. Alternatively, and this way will likely give the greatest amount of control, one can output the currently open Rhino file as an MXS file. Let's assume that I've done a marvelous texturing job on this Eames share and that I'm really happy with it. Then I should first save the Rhino file. In the second step, I could output just the Maxwell scene file. What now takes place is all sorts of render preparation, but the offline engine doesn't actually start with its calculation. With this in place, I could open up any interior design scene and load the Maxwell file I've just created. One can do that by toolbar button or via command line. I personally use a custom right-click menu, which opens the file browser right away. One may then decide for one of the options to display the chair in a simplified way. Point cloud is quite nice because it still shows the workpiece shape. And just as with normal blocks, I still may transform single instances individually. As soon as one presses the render button, the external content is merged with the current scene and everything renders like normal. Using Maxwell's scene references probably makes a lot of sense if one wants to build a library of reusable content, which one maybe also shares with colleagues who possibly sit in front of other 3D programs or who use the renderer from macOS or Linux. Scene references will provide reliable output in all of these cases. All one had to make sure is that textures are stored in a network location everybody can access, because textures are not stored in any of the MXS files. By using Maxwell's scene references, one simply can make sure that the model gets loaded in the most efficient way possible and that things look alike everywhere. If one, however, at some point wanted to update the source file, this still was possible, actually in two ways. One could open up the MXS file in Maxwell Studio, or if one also has saved the Rhino 3DM file, one could do the changes here and simply re-export. Scene referencing is, by the way, also in use in Maxwell's scatter extension. What here looks so flowerish or kind of like bacteria is just thousands of that chair randomly scattered on a sphere. One can even use any of Maxwell's special effect extensions, such as grass or volumetric simulation, inside referenced and scattered scenes. Here's quite a few swimming pools, all with a silly little ocean simulation going on, brought into the scene through scatter extension.